Hello, everyone. My name is John Owen. I am the Regional Technical Specialist for the Phoenix, Arizona area for Iscar Metals. What we are going to go over today is the electronic catalog and other web resources that Iscar has available. Best place to start is going to be with the e-catalog. So let's get going. First thing I want to mention is the difference between the USA side of the website, which is the iscarmetals.com website, and the worldwide version of iscar.com. If you go to the Iscar Metals website and you click into, scroll down a little, and you click into the e-catalog, it defaults to the inch setting. If you go to the worldwide site, iscar.com, and you click on the e-catalog, it defaults to metric, and you have to change it right up here in the upper right corner. Now, I will mention the number one issue that people tend to have when coming into the e-catalog is making sure that they choose either inch or metric, whichever you prefer. I get more questions about that than probably anything else. So let us get going here. We'll just start here. I've changed it to inch. Normally this bar here would start out expanded and unpinned. There's two options here. You can either collapse the bar or you can pin the bar. Pinning the bar puts it right there and it will stay there. If it's unpinned, it follows along with the page. So we're just going to pin that bar for the moment, but we will get back to that later. The easiest search right now to start with is via an EDP number. So we'll just type one in and take a look at what we get here. 847, and you can hit enter or hit the little magnifying glass there. And that will take you directly to the tool that you typed in. All the information on it, generally a picture. You have, most of the time now, we have 3D models available, both light and detailed, if it's available. If it only shows a light one and you hit detailed and it shows 3D or detailed required, there's an option there where you can request a detailed model. So it shows all of the dimensions here. You can change from the ISO to back to the older style if you're more comfortable with that. The designations here for inscribed circle, the radius, feeds and such. Oops, click that back. In this particular instance, there we go. The items are pretty much standard. I'll show you a different a tool holder here and you'll see some differences. It also shows, if it's an insert, it shows all the grades available for that insert here. Now, I'm not going to go too far off from this right now, but if you are curious, you can click on a grade here, and it will take you to information on that specific grade. This particular one, I see 806, says tough submicron substrate, Tylon PVD coated, followed by special Sumotex surface treatment. This is great for Inconel, also works quite well on stainless steels. It will show generally information down here at the bottom for material types and general cutting speed recommendations. Let's go back to the insert though. So you can click on any of those. I'll show you a little bit more about that later. So if we go up here, if you look up an insert, it will show the related tool button here. So we have, in this case, our Logic 4-turn insert, a CXMG 090402-F3M, which is the chip breaker. If you click the related tool, every tool holder that will hold that specific insert will be brought up here. You can click on the link here. And here it will show, you see up here, more information. We'll go into that in a second. So we have 1/2 inch and 5/8 versions of tool holders that will hold that insert. both left and right-handed. This particular one is jet cut, so it is coolant through. You can choose one here. Brings you down and you have more information. Now here is probably a better view of the new standard, the ISO standard. You can click on non-ISO and it should change some of the items here. You can scroll down. Here we have the light model. You can click on the detailed model. Don't think there'll probably be much difference here. You can download this model. Anytime there are spare parts, keep scrolling. It'll show all the spare parts down below, including the name or description and also the EDP number here. Oops. There you go. So now up here you can go into more info and it will have more information on the tool holder itself, setting it up, showing the frontal coolant holes, showing the breakdown of the tool holder there. Lots of information there. Scroll back up. Now from here you can we'll go to accessories real quick. So it does show some of the high pressure coolant lines here that you can get for it. But from here you can also hit related insert and it will take you back to the insert where we started. So we'll go to the M3M, which is a medium machining. Now here quite often you will get a pop-up if there's current promos available on this. Sometimes these promos are worldwide and not necessarily available in the US, but if you are interested, please check with your local sales rep and we can certainly check that for you. Clear that out there. So now we're back to the insert. Again, if you click on the insert, again, in this particular one, it only shows one grade available. It's a CVD coated for stainless steel, a little bit tougher, good general purpose grade there. Back to the 3D model. Okay, so that's one way to look up something. Now you can also search for via a description, a partial description. So we're going to go back up here and we're going to click new search. Go into the box here. We're just going to type in HM390 FTD. As you can see, I've looked this up before. Hit search. Okay, now it brings up everything that starts out with that. So these are all Heli Mill 390 or Heli 3 mil. These are face mills. So we start out 1.5 inch diameter up to 8-inch diameter. Let's just pick 2-inch diameter here, 5 flute. If you click on the EDP, again, it takes you to the information page for the cutter body itself. Here's a good example of the light model. Okay, change to detailed. Now you got a nice looking face mill there. Again, scroll down, you have all your spare parts, screws, your Torx wrench. Okay. Now up here, you can go to related insert. This is basically all the exact same information. We just looked it up differently. Instead of an EDP number, we looked it up via a description. Click on the insert. Now here we have a lot of different options. So here we have different chip formers, an MP chip former, general duty. If you hover your mouse over each one, it should give a general description of each one. Here's an insert with a serrated chip splitter across the cutting edge. This is the standard insert. GW, so that one does not have a description here. The FW chip splitting insert. Here, and you get down here into the different radiuses of 1.2 millimeter, 1.6 millimeter, 2.0 millimeter, and so forth. So let's just pick the standard insert. Okay, so again, you have a nice picture here. Scroll down a bit. You got all the different grades available here. Again, you can click on the grade, takes you in here to the information, all the recommended feeds and or cutting speeds here. If you go back, you'll see that there is a min and a max feed rates here. So the minimum FZ minimum is 3 thou and 1/10, and the maximum is 5 thou and 9/10. Gives your minimum depth of cut here also. So let's go back to new search here. We're going to do one other searching method here. Excuse me. You can choose an application along here. So grooving, parting, turning, threading, milling. We're just going to go hole making. And we're going to choose just drilling. Now it gives you a big long list of all the drilling options for more of a standard type drilling, like our DR indexable drill or our very popular sumo cam drills. So let's pick one here. Let's pick a 12 times D. Okay, so now you get back to the exact same information. This one brings up all of the different sizes. So in a 12 times D sumo cam drill, we start out at 315 diameter, or 8 millimeters, and go up to just over 1.25 inches, or actually just under 1 inch, 300 thousandths. So let's just pick a standard one here. Let's pick 1/2 inch. So that would be, you got the range here, DCN, so minimum, and DCX maximum. Again, if you hover your mouse over it, it should bring up a small detail. So let us choose this one. Okay. And again, here it shows the minimum and maximum. The shank diameter, decons 625 diameter. Come down here, again, a light model. Click here, you got a detailed model. Scroll in a little bit. Scroll down further and you have the accessories. Go to related insert. Now here's all the options that will fit in that body. So let us choose, let's go HCP here, this one right here. This is a perfect insert. You don't have to do a pre-hole or anything. Mounts on there. It's mostly for alloy steel and cast iron. Choose a 1/2 inch. Here's all that information. Again, this one only comes in a detailed model. So there's your model. Should be no accessories with any of the inserts, so there won't be anything down below. All right. So most of the time you can go to more info. We'll generally have the feeds and speeds information in here. And there we go. So because this particular insert, the HCP, is designed for steels and cast irons, it's only showing feeds and speeds for steel and cast iron. So if we choose a material, we'll go low alloy steel, kind of go middle of the road here, about 300 Bernal. Okay, you look here, 200 right in the middle, 230 surface foot for a speed, and then we'll look over here. So that's the range, 1/2 inch is in that range. We'll go back down here, 9 thousandths per revolution for a feed rate. These numbers, all of these numbers are dead in the middle. So they have minimum numbers that are below that and maximum numbers that are well above that. So they take the middle third and put these in here. These are very, very predictable numbers. Okay, so now let's go back here real quick. We're going to do another search. We're going to do some wildcard searches. You can do a specific search for a grade. So like one of our new Inconel grades, go // and I can tell you that if you hover over the little I there, it will tell you what the wildcards are. So the options there. So we'll do //804, hit enter. So every insert that we make that comes in IC 804 is going to be listed here. So we've got CCMTs, CNMGs, DCMTs, we've got grooving here, more grooving, lots of grooving. So there's 2 pages. Some of these grades have a lot more than 2 pages. SNMG, VNMGs, WNMGs. So it's a really nice way to look up if you have a grade that you really love. You can look up and see what all is available in it. So you can look up, say you like the M3M, the new M3M chip former for stainless steels and high temp materials, and you want a CNMG 432. So go CNMG, and we'll go %, and look, I've already looked it up before. M3M, hit search. Okay, so now every insert CNMG with an M3M chip former is going to come up here. Comes to page 2, so go back to page 1. There we go. CNMG 331, 332, 431, 432, and so forth. Okay, you can also look up, let's change this one item, let's go F3P, and then go //IC 8250. Okay, so everything CNMG with an F3P, which is a finishing middle feed rate for P-style materials in grade IC 8250, is going to come up. 5 inserts. So CNMG 331, the little flash turn, up to CNMG 433. So it works out real well if you definitely have some specifics. So let's do another type of search here. I like hitting, rather than just clearing that out, if we're going to do something new, I just like hitting new search. It makes it a little bit easier. So we can also look up by grade. Okay, so you can click by product down here, and you can click grade info. In the main application filter, you have to choose something. It doesn't matter whether it's threading, milling, whatever. You just have to choose something and then put your cursor back in the search field and then hit enter or hit the magnifying glass. What this does is it brings up a grade search for every grade, current grade that we have, from CBN grades, uncoded grades, IC 07, pardon me, up to the old standby IC 328, which has been superseded, but it's still a great grade, up to IC 5400, medium temperature CVD coated grade for milling, on and on, 6025 for stainless steel, 807, that one's been out forever, superseded, it superseded IC 907, which is still extremely popular out there. There's the 8250 we just looked up, IC 882, and so forth. So every one of these grades, if you click on it, an ID5, so it's a PCD brazed tip man-made diamond. So lots of information there. Okay, you can also we'll do a new search. You can go by family, and we'll go milling. Click search. Okay, so here is a lot of milling. Okay, so you can look it up that way. That's probably not real useful, but by brand name and hit search. Now it brings you down to all our current brand names. So let's go down to, let's look at Heli 3 mill. So all the different options for Heli 3 mil are available here. So we can go into, click the item there, and we can go to back to the same cutter that we looked up earlier. See information, the detailed. So now let's talk about assemblies real quick. You can make an account on here. I'm just going to go back to new search. If you click login here, it will ask you if you want to create an account. Of course, I already have one set up. We're going to sign in real quick. The nice thing here is you can actually build models and save them as a full 3D model. So I'm going to go through this reasonably quick. So I'm just going to look up EDP numbers. So I know that I want to use the 310-6804. I'm going to go search. So we're going back to this 2-inch 5 flute cutter. And right here, down here, you'll see Add to Assembly. Click that button. Take you to another window. Okay, and here you have the cutter body. So now above it and below it, you show the insert and the tool holder. So let's go ahead and just add a holder for the moment. So you click on that button, it'll give you all the different options for tool holders. Let's just choose HSK. And so here's all the HSK holders that will hold that cutter body. It's a 3/4 inch pilot. Okay, so let's just go HSK A63, click on that. Once again, see here, you have Add to Assembly. Okay, now we've got two parts of it. Let's add the insert. We'll choose that. And once again, we're just going to take the standard insert here. And right here, along this whole line here, all the different grades, click Add to Assembly. Okay, now we've got all three items here. So up here near the top, you have a proud button now that says Build Assembly. Let's build that thing. Takes just a minute, and now we have a fully built assembly here, including the inserts. Now you can either download that as a full model, or you can also email it and save it to your account here. So that is a very nice little option there. Okay, so let's go back here. Oops, actually new search. There we go. So now let's go to the floating toolbar. Okay, let's open this thing up. I'm just going to move it over here. So I'm just going to go over each item real quick, and then we'll go into each one. You can go back to the home page here. You can go to the Iscar Tool Advisor. This is a big one here, the machining power calculator, which we'll spend a little bit of time in that. Mill thread advisor, including generating NC code. Productive geometries for crossing over something, including also grade optimizer for crossing over something. Industrialize, so that is a lot of information. We'll spend a tiny bit of time in there. And then Tech Talk, we have a YouTube channel under Iscar Web, and we have Tech Talks on there, and it's quite interesting. They are pretty active on there, and there's lots of information there. But let's start up here at the top, the Iscar Tool Advisor. So, as I was mentioning at the beginning, the most important thing is choosing whether you want metric or inch. The ITA, or Iscar Tool Advisor, is the one spot that it's actually fairly hidden. So you actually have to look for it. And so it's good to know where it is. And it is in settings. And it defaults to metric. So you would click inch, save changes. Okay. So now we are going to just pick a tool out here. What this does is you can put parameters in here. and it will give you options for tools to use. So we'll click milling. We'll just click facing. So here you put some details in here. You can get very detailed tool, optimizing the tool, optimizing the application. If you have information on the machine and the adapters, we're just going to leave it as low alloy cast steel. No problem there. We're gonna, when you go into the depth of cut, it gives you a visual representation. So we'll say 0.125 for depth of cut. Width of cut, we'll say 4 inches is fine. The length of cut, let's make it a bigger part, 60 inches. Okay, all the rest of the information's there, and click search. Now what this brings up is some very good options. I still prefer the our salespeople for choosing an option because they can see your application, they can see your machine, the setup. So this is a very impersonal way. It will get you going, but I still like having a sales guy there or myself there choosing a tool. So in this case, it has chosen the Heli-Do, which is a 45-degree cutter, and gives you the options here. It should show, you hover over that little icon there, it will show you a picture. Okay, we'll scroll down a little bit. It should show a picture of the insert. Of course, you have to hit the X there. And then, oops, where is that? No, it should be showing a picture. It shows kind of a picture there, the edge of the picture, but it will show you the insert, the grade recommendation, the information here. It will actually give you surface footage and feed rate recommendations. So it is a nice tool that you can use. It usually gives you at least a couple of options. You can download the options. It gives you links directly to it, EDPs, all the information. This is definitely a good place that you can play with. So let's go back to the machining power now. Let's go back here, and we're going to go to machining power. Most of these open up in a separate window. Now, there's a lot of information in here, so we're just going to burn through it here real quick. This is, again, a great place to play in. You can see here where it's a little more obvious whether it's inch or metric. We'll just click milling. We're going to do shouldering. We are going to do, just do straight edge, make it nice and simple. Cutting diameter. Now, when you put the information in here, you don't have to put all this information in here. This information does transfer completely down the list here. So if you put all the information in here the first time, there's very little information you have to add on each calculator. So let's just go 3 inches for a diameter. We'll go cutting width, and just go half. The edge count, so we'll say 6 inserts. We're gonna say nice general 0.005 inches per tooth. Depth of cut, 0.125. Cutting speed, we'll say 500 surface feet. Let's choose a workpiece material. You can go into an extended materials list, but we're just going to choose, what's a good one there? 304 stainless. We all love that material, don't we? Okay, cutting edge angle, I'm just going to go 90. Effective rake angle, we'll leave blank. Calculate. Oops. So you have to put that in there. 0. Calculate. Oh, there we go. All right, so it gives you some information here. Power demands, material removal rates. If you go down the chart here, so we have a 3-inch cutter, you see, 500 surface feet, which is 636.6 RPM. You can put this in here if you want to go backwards. If you want to go 800 RPM, it tells you what that surface footage is. Go down to the next here. For feeds and speeds, we'll go, there we go, shouldering. So again, it already has the 3-inch, 6 flutes, 5 thou per tooth. All the information's there. Calculate 24 inches per minute. So power and torque, just choose straight edge. Again, all the information transfers down. 5 thou per tooth, 0.125 1/8 inch depth of cut, your feeds, your speeds, I should say, the material. Okay, this was at near the beginning, so the net mean power demand is about 6 horsepower, max power about 9 horsepower. Material removal rates, all the information is already there. So 4.5 cubic inches per minute. Cutting forces, calculate. Spindle bending force, max tangential force. Chip thickness, this is a big one here. This is if you're doing less than half the diameter of the cutter. And this is where you have to do a little bit of research. So we're going to stick with our 3-inch cutter, but instead of 1.5 inch radial engagement, we're going to do 0.25, so a 1/4 inch radial engagement. Feed per tooth, 5 thou, we'll leave that alone for the minute. That's where we're going to change things. We're just going to stick with 90-degree cutter. Okay, so what we're looking for is to get our average chip thickness up to just above what the minimum feed rate requirement is for that insert. Now I'm going to go back here real quick. I'm going to pin this out of the way for the moment, and I'm going to look up the, we'll just go here real quick. Oh, there. And we're going to choose that cutter again. You can, if you have the EDP for the insert specifically, you can just go to that. You can type that in. I didn't have it handy, so we can choose that. Okay, so now we have the feed rate minimum, feed rate maximum. So what we're looking for is this feed rate minimum as an average chip thickness plus about 25%. So that makes it just under 4 thousandths per tooth, I believe. So we'll go back here. So we need to get this number up around, we'll say 3.5 thousandths per tooth. So we start raising this number. So we'll go 8 thou. And we're getting there. So we'll go 10 thou. No, not yet. So let's go 12 thousandths. There we go. So now our average chip thickness is above the minimum feed rate requirement of that insert. And now you are not rubbing that insert. You're going to get your best life with that. You're actually shearing the material. So you're feeding it 12 thousandths per tooth, but you're actually, your actual feed rate ends up generating about a 3.5 thousandths thick chip. So you can really do some improvements with this in your throughput. Cutting time. So again, we have the 3-inch diameter, 6 teeth. And as I put the 12 thousandths in there, it transfers down, of course. If we put the cutting length in there, we'll say 60 inches. So 1 minute and 2 seconds to do that cut. And then the last item, max spindle bending moment. So if we scroll up here, we'll just stick with the straight edge theme. Here, the only information you have to add is how far the tool is hanging out. We'll say 10 inches. Calculate. So spindle bending force, 460, basically 465 foot-pounds. Spindle bending moment, about 183 inch-pounds. So There's a lot of information in here, a lot of stuff to play with. Okay, so now let us go and look up the mill thread real quick here. Let me go back up here. Go, whoops, about certain search. And open this back up. Okay, so that was machining power. Now we're going to go on to the mill thread advisor. Okay, because this is the part of the Iscar tool advisor, the metric and inch is hidden in here also, just like it was in the regular one. So I've already had it to inch, so it should stay there for each session. So let's just go thread milling, bring that back up. Okay, so application details, again, you have tons of information you can add in here. The main one, though, is application details. We're just going to choose internal, which is already selected. We're just going to leave it as alloy steel, but you do have actually, let's change it to stainless steel. There we go. If you know the hardness in either Brunel or Rockwell C, so the thread style, going to UN 60 there, 60 degree. We'll go 20 threads per inch. Now, I'm just going to choose, you can put a custom diameter in there. I'm just going to choose 1/2 inch 20. Okay, so there's all the information. Go search. And if you're missing something, it will tell you, which is, I forgot to add the thread length. We'll say 3/4 of an inch. Search. Okay, so it gives you a couple of options here. Multi-master there, and the head. Let's see if it shows it. Nope. Still won't show it. It does give you a link to the e-catalog. Okay, so from here you can choose the tool, and then you can go up here to the NC generator, open in a different window. In here you have, again, lots of options. This shows there's the actual picture of the head. Shows all the information there. Go next. You can choose your path type, continuous or axial divided, how many passes. Next. You can change your cutting speeds here. Let's just change that to 150. Changes the RPM there. 5 inches per minute, circular feed. Okay, you can give it coordinate, will not change that, but you can change the controller style. Plenty of options in there. We'll just leave it in Fanuc. You can choose whatever, or tell it whatever tool number you need. Do offsets. Click next, and it generates the code right there. You can either select it all and copy it and paste it into your program. You can print it, save it, whatever you need. So it's a nice little tool, very quick. To get you information there. Okay, so we close a couple of these windows. So now we're back to the floating toolbar. We're going to go into the productive geometries. Okay, and here, if you have another brand of tool and you want to convert it over, you can go in here and we'll just choose, we'll pick on Kennametal for a minute. Let us choose their high feed milling. Find Iscar's equivalent. Okay, so it's going to be our FFQ4, so fast feed Q4. It's a square insert set on about a 17-degree angle, if I remember correctly. Good for, looks like all the different materials except non-ferrous. Sure, it would work in that also. So let's look at a different one. Let's look at Who should we pick on this time? Mitsubishi. Let's look at their isoturn inserts. And we'll go, let's pick an MJ chip former, Iscar's equivalent. Well, there's the M3M, that's the brand new. So medium, middle of the road feed rates, and then the M style materials. That one supersedes our old style TF, which is still a great chip former, but the newer ones are definitely better. So let's look up one more here. We'll pick on, just so we spread the love here, we'll choose Sandvik, and we'll go parting, and we'll choose 4E, Iscar's equivalent. So here's the equivalent chip former. So for steels, it would be a P chip former, stainless steels, the MF, which is a great one that would take care of both steels and stainlesses, do quite a nice job. But it gives you good options there for choosing the chip former. We go to 5E, which I believe is their version of our J. Yep. So now you have a more positive, a little bit lower feed rate. Works out real well. So now let's take a look at the grade optimizer. We'll close this window. Go back here. Go to grade optimizer. At least on these, you don't have to worry about choosing metric or inch. A bonus. So just because we already picked on them, we're going to pick on them again. Kennametal. And let's look at ISO turning. We'll look at grade. Let's look at grade about 5010. There it is. Iscar's equivalent. So IC 807 or 907. So again, the 907 is the older grade, been superseded by IC 807. Both are still available, but the IC 807 is definitely a benefit. Moving to that, you'll generally get about 20% more life and plus a little bit more speed. In the high temperature alloys, the IC 806 is the one to use. So it's a very, very simple way to convert over. So let's do one more. We'll just choose Sandvik this time. We'll do their milling. Let's go 1025. So again, here we are, IC 808 or IC 907. You have tougher options here, so you can step up. So it's a nice little system for converting things over. Okay, so let's close this and let's go back here. We're going to go to the industrialize. Okay, this is kind of a dream site. You kind of look through here, and these are all the different things. Lots of different options. Let's look at a knee joint, since I need another one. So here we have pictures of the part itself. If you hover over each one and click on it, it will take you to what the recommended tool is. Takes you to a YouTube video here showing how it's used, what it's done with. A little better picture of the tool. Let's go back. Let's go back one more. Well, let's look at, how about a Blisk in Inconel? Okay, here we definitely have, so rough facing, rough face grooving. Let's look at that. So again, it shows the insert, has a nice video showing the application itself. Lots of information in here. You can definitely get lost in here looking at videos and different applications. Let's look at just one more here. This is a new one, jet engine blade. So you got the root profile milling, the blade root radius milling. Let's just look at this real quick. Okay, so this is a special multi-master head. And again, it shows the profile there and how it's used. Very slick system. All right, let's close that, go back here. Oops, back into the electronic catalog. See, I went there from iscar.com and it defaulted to metric. Just change that real quick. So that is pretty much most of this bar. If you go to the Tech Talk, it will take you to the video. Shows all the different Tech Talks. I'm just going to go back now real quick. We're going to go into the Publications tab, which is back on the original page here. So we'll go up here, scroll to the top. You've got Publications. You can go into the brochures here. Gives you all the latest brochures. All of these are available PDF right here. So let's take a look at one. Let's look at parting. This is our new parting system. The Logic F grip. Very, very rigid. This gives you the whole brochure. Some information about the tool. How rigid it is, how solid it is. The tool descriptions. Blade descriptions, insert descriptions, and so forth. We can look at another very nice one here is fast feed milling. So there'll be inch and metric versions here. So quick tool selector guide. Go through here. High feed milling chart, information, the different types of inserts that we have. Okay. Scroll down here. This is a really good one. It does not have to be high pressure like it says here. Even standard pressure, you can generally get double the tool life on most turning applications. The higher the pressure, the better it is, but it does not require high pressure. So all kinds of information on that. Okay, so let us go back to Publications real quick. Go back up here. Now you can go to the catalog here and you can actually download the entire catalog. I don't see a lot of need to do this, but they are here. All of this information, of course, is online. If you do need it offline, though, it is here. Okay, we can go to Reference and User Guides. Here is one of my favorite new guides, the Machining Titanium. There is a wealth of information in here, 60 pages worth of information. Machinability, titanium grades, milling titanium, the different grades used to cut titanium, drilling shallow holes, and so forth. Lots of very good information in that. The Whisper line, our new line of D-Vibe boring bars. Lots of great information there. Now there's one last thing I'm going to show you real quick. Close that, go back here. We are going to go into the product lines. And this one, unfortunately, is a little hidden. I want to actually try and have them move that to something a little bit more prominent. But if you go in here to wear resistance, it will take you to a guide, basically a troubleshooting guide showing different insert wear patterns and solutions. So let us go, let's just go milling. We'll go indexable inserts. Okay, so that's highlighted now. Now, if you go down each one, if you click on it, which is, this one's the default one, flank wear, gives you the cause, which is actually, this is what we want unless you have excessive flank wear. Go to crater wear, Gives you the cause here and some different remedies. Nice little visual representation of that crater wear. Notch wear, cutting speed is too high or insufficient insert wear resistance of the grade. Built up edge generally means you're not going fast enough. Yep, cutting zone temperature too low, too negative a cutting geometry, cutting very sticky materials. So there's lots of options in here. So you can, let's go back. Let's choose a different one. Let's go to ISO turning. Same thing. If you get, we'll say plastic deformation, shows you good representation here. Cutting temperature is too high. Generally, you need a more wear resistant grade or reduce the cutting speed. Generally, those are the solutions, but all of that information is right here. All right, well, that is the end of the program here. That pretty much covers everything. The best thing here you can do is to just get in there and play with it. There is a ton of information. Again, you can save that information if you're logged in under the account. We'll just go back here real quick. Change it to inch. Click the login. Remember here, you can create your account here, and then you can save any of your models or other information into your account. Go into favorites. You can save favorites. I've saved a couple there. So it's nice to have a little account there. Grades guide. So there's a lot of information on here. So thank you for listening. I appreciate it. If you have any questions, do not hesitate to contact your local sales rep or regional technical specialist, and we'll see you out there. Thank you.